Welcome to week 6. We've all been very busy. So lots of little updates. And let me go through all of them, hopefully not forgetting any. The first is that somebody noticed that if you unfolded the calendar, it had the test on the wrong time. So we fixed that Saturday night. I think the best time to do our second test is week 7. And that's not great because President's Day means that the only thing we would do that week is have our test. Let me actually have that open. So for the 15th, we don't have class. So I will see you now. I will see you Wednesday, and then it'll be a whole week, and then we show up for a test, which normally would be terrible and evil. But I think since we are doing midterms in a friendlier, halfway cooperative manner like last time, then you will all study a whole lot so you don't embarrass yourselves before your peers. But if you don't do as well as you would like, because it's been an entire week since you've done any of this formally, then it's not so bad. It's not like your midterm is part of your grade. Could you schedule something on Discord or something? Are you asking about Monday in chat? Yeah, let's get to that. But first, I just want to make sure that the 17th is not a remarkably bad day where people are going in to have their tonsils removed or things like that. So if the 17th for the test is dreadful for your personal schedule, holler to me personally in chat or say something now. Otherwise, I think that we'll have review for this week, a test, and then we'll just move on to probability. And that will have a better flow than if we try and switch to probability before the test or things like that. Any comments from students? Zoom keeps pausing all of your nice people sharing smiley videos. Sometimes you just stop moving. So I'm not sure if you're actually being quiet and don't have anything to say or Zoom is crashing. So test on 17th, I will stick it on the calendar officially. Okay, I see nods. The week 6 to-do list is ready. And just like before, it has 2 to-do lists because there's a test prep thing. The test prep is better this time than last time. There was not an answer key for Paula's review sheet. Now, if we look at her review sheet, which we might do somewhat together in class on Wednesday, but it's good to do yourself, then it actually has an answer key this time. So that's much more helpful than last time when her review sheet didn't have an answer key. She also provides us with a nice warm-up, some Google slides that kind of walk through some of the issues with presenting data and ask, is this okay or is this not, or things like that. So more things to review with. One thing I will need your help with today, but I don't want to interrupt the flow of announcements with it, is if we actually look at our test, it has too many problems. As I shared in the email before, I want there to be between 20 and 25 problems, and right now there are 36. And that's just because I haven't taken off any from the previous topics from problem solving and finance. I've just stuck extra things on midterm 1. So we'll talk about later during class which of these are needless. I don't need to keep you on top of your game reviewing them. You will be fine for the final exam if we leave them off the second test. But we have too many problems there. Oops, I'm not sharing my screen, am I? That's part of the problem. Okay, let me back up again. Sorry about that. I wish it told me more obviously. Okay, so the 17th is our test. We have a day today, another day Wednesday, nothing on the holiday. We will probably organize something, and then Wednesday we will have our test. Now you're all looking much more engaged that I'm sharing my screen. See, I've learned my lesson. And then for the midterm, when you come down, week 6 is ready. And what I thought I was showing you before is Paula has a review sheet with an answer. Can be helpful. And then she has this nice thing about a warm-up that has a Google Slides with questions that will help just review things before the test. And we might do this together, but you can also look at it on your own. So all of that is in the things to study for test 2. When you go to the practice test and I flood you with that link, you get to see it here, you get to see it here. You can click on the little box that says test week right there. Then this has 36 and we want there to be 20 to 25. So we'll talk about which one of these to get rid of. Okay, I'm putting Katie to sleep because I am repeating myself too much, but I'm sorry, I forgot to share the screen. Week 7, there won't be much. There's just the test. So you don't have any videos, you don't have much of a to-do list like that. And this week, there won't be normal homework, just like before. If there's a test coming up, do 2 practice tests, and that's your homework. Questions so far, now that I'm remembering to share the screen? No. Okay, so the things that I know you have questions on, first of all, the Jamboard today is prepped with lots of things. The first 10 pages of our Jamboard, people have turned in some homework, week 5, part B examples from your life of these things, and I've put them all together, 1 per slide. And we're going to see, talk about which of these answers are good or not. If you want to share, that's mine, then you're welcome to. But I am keeping people anonymous unless you tell me otherwise. So we will go through that. Then we'll talk about the week 5 quiz, partly because number 2, boo hiss, was a trick question. And you will remember the answer better if I am evil and you hate me because I put a trick question on your quiz. But it will be a good thing to remember. And people got 1 and 3 right fairly often too. And then we'll talk about the new topic today, which is standard deviation. So that is our game plan for today. Questions about things before we get started? Nodding heads, no. Okay. Well, let's talk about the part B thing. So kind of just for the sake of the recording, if we looked at part B's homework, then it was not a normal homework. It just had 10 questions about give examples of these things from your life. So let's see what people shared. First, a percentage that is part of a whole and a percentage that is not part of a whole. So one person said 50% out of 30 children is 15. Is that part of a whole?
Yes.
Yes, right. The 30 is the whole, half of it is 15. Oh, I should also add, if these are yours, then there's an achievement for problems on the board in class. This one and a second problem on the board. So if I use yours once or twice, let me know in chat, perhaps privately, and I will check those off for you. The level of humidity is 30% above normal, part of a whole.
Would that be no?
The
Because
30% humidity,
what is normal?
the 100% humidity is actually fog, not rain. It's not really a whole of anything. So humidity could be considered not part of a whole. So good job with that one. How about this person? Food is an example of percentages. If there's 6 slices of cake and you eat 3, then there's 50% of the cake left. That's part of the whole, right? It's 3 out of 6. If you ate 6 slices, that's 100% of the cake. That would still be part of the whole. It's still 6 out of 6. And there isn't a whole cake yet, but both of those are part of a whole. Someone with blue font wrote, 50% of my plants have purple blooms. Is that part out of the whole?
Yeah.
Yeah, so many plants out of all my plants. All my plants is the whole amount. There's a 10% chance the pink ones will bloom. Is that one not part of a whole?
Yes. And I really like that example for whoever did that one.
Thank you. That was me.
So if it has a percent chance, that usually means, almost always, it's not part out of a whole. That a chance, it doesn't actually happen that we do 100 cases of this and say, oh, 10 of them bloomed. There's not 100 experimental pink flowers out there. So chances are a good one. With the white on black, 50% of my clients are impoverished. A 10% chance my next client will cancel before our meeting. Did that person do the assignment well?
I believe so.
So 50% of my clients, whenever you have the word of, that's going to be part out of a whole. So we don't know how many clients there are, whether it's 5 out of 10 or 10 out of 20, but that is out of some large amount. Whereas again, a 10% chance, we're not actually having all the chances happen. There's not a whole set of outcomes there. So that is not part out of a whole. Okay, next one. 65% of the elephants are male at the zoo. I see nods. That is out of the whole. So male elephants out of all the elephants. For the other half, 14% of the animals are elephants at the zoo. I see nods. That's another part out of the whole. Now it is elephants out of all the animals. What counts as whole has changed. Here it was elephants, and here it was all animals. But it's still a part out of some other whole. So both of those are part out of wholes. Whoops, this one I think is on the wrong slide. That might mean a bunch of the ones with that smaller font are in the wrong spot. I will finish fixing that later. Let's keep going with what we are. This person says, I have 12 patients. 9 of them are females, the other 3 are males, 75% are female. Part out of whole. What do you think? Yes, no?
Let me guess.
Yes, the total patients and then the parts are either male or female. 25% of my patients have elevated heart rates and hypertension. That's going to be another part out of whole. The whole is still all the patients. So it can be tricky to think of percentages that are not part out of wholes. We're so used to that. Last one, 75% of my children are girls. The weather has a 10% chance of rain. Did that work?
Yep.
Yep. Right. Girls out of all children is part out of whole. but 10% chance is not part out of a whole. On the next page, categorical data. So book, 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 manga, 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 light novel, Legos, Lincoln Logs, dolls, kinds of toys, types of pens, Sharpies, gels, erasables, highlighters, felt tips, kitchen utensils, spoon, 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 spatula, whisk, categories of pets, rabbits, dogs, and cats, favorite colors, favorite foods or foods I've eaten, whatever that might be, types of shoes, running shoes, boots, flip-flops. So counting types of things is great categorical data. Quantitative, it means the data is how many times numbers happen. So what are my allowances? That's great. How many of each toy there is. If you have how many of each kind of pen, that's still categorical. You're just counting them. You're not counting numbers. Actually, how many of each toy is the same. I said the wrong thing. So if I have 8 Legos, that's still categories. I'm still counting Legos. I'm not counting 8s. Unlike here, where I'm counting how many kids get $10 for allowance. So if you're counting numbers, that's quantitative. So the pay per client, then yes, we're counting numbers. How much babies weigh, we're counting numbers. How many days people take showers, we're counting numbers. And then this one is interesting. I work 5 days out of 7 each week. So that data set has only one value. You asked how many days do you work each week, and you only asked yourself and you said 5. But that's still a good data set where you're counting numbers. Even if you only asked one person, it's not a very interesting survey, but you are counting a number. So there you go. Is it helpful to be going all over this? Am I going too slow? Am I going too fast?
Good.
I think this is really helpful.
Yeah, really good.
A list of data whose mean and median are very different. So the math tests, then don't worry about arithmetic sequences. That's not quite the right thing to say anyway. But yes, we won't all have the same test score. So the mean and median could be different or could not. We're not quite sure. If it's very symmetrical, they would be the same. If they are skewed to the left or right, then they wouldn't be. Pardon me as I fix things again. Okay, there we go. So monthly expenses on car maintenance, a bunch of zeros and 3 of them that had values. So if you add them up and divide by how many, you get a positive number. But if you just list them and pick the middle thing, it will be a 0. How many days you walk each week. So we add these all up. The mean is the sum over how many. So it would be 2 divided by 7. Let me write that in there. So 2 then so about 0.3. But if I look at the middle of the sorted list, it is it's going to be a 0. Let me highlight just 1. There we go. So 0 and 0.3 are different. How much you spend at the grocery store when you only shopped 1 day. So you add them all up and divide by how many and you get 10, but the middle of your sorted list is 0. Here's home prices, salaries. I don't know what these are, probably salaries. So one person earns 50,000, 4 earn 60. Most people in this sample earned 70. 15 people earned 80, and 1 person earned 90. So the mean is 14.2. That I'm not sure how the mean is lower than any of them. That seems very suspicious. But it will be different than the median. quite sure about these numbers, but that sample size would make this work. Households' average weekly food expenses. Again, the zeros mean that the median is going to be smaller than the mean. I don't think when you sort this list, you actually have a median of 0, because there's 3 zeros and the next thing will be 15. So I think the median for this is actually 15. But it is still true it's different than the mean. And then someone wrote it as a frequency table. The 4 days with a 0% chance of rain. Yes, when I sort the list, the 4 zeros will mean the mean is 0, median is 0, but the mean is something bigger. So far, so good. To make the range greater than the highest value, you need a negative number. So having temperatures with a negative value, having a negative here, having how many minutes you run without stopping. I'm not sure what a -5 means then. I'm not sure how you run negative minutes. A temperature with a negative. In any case, if you do that, then when you take the highest minus the lowest, subtracting a negative means you add. So 40 minus -3 is 43. The mode means everything is different. So with these orange numbers here, there's 2 modes. So that list has 2 modes, whereas this list has no mode because nothing is repeated. So as long as you didn't repeat any numbers and one of them was negative, that would work for this problem. A high standard deviation means the numbers are scattered all over the place. 0 would mean they are all identical. So for the first person sample, then over 12 months, what did they pay for their car? So scattering all over, the deviation is going to be not 0, but bigger than that. Then just for the first 3 months, when it was only 3 zeros, the deviation was 0. In blue, the weight of my backpack in the past 2 days. It was 35 pounds both days. They're identical, so no standard deviation. If my children picked their favorite colors, if they have 59% of my children picked yellow, you have an awful lot of children if a survey would have 59% of them. But anyway, then yes, that one has high standard deviation. If they all pick colors with 20% of the picking each color, that's all the same, no standard deviation. Somebody writes, calculating the class average on a test could have a high standard deviation. Everyone could be far from the mean. A list of data that has 0 deviation has no change, or the outcome has no change. Everything is the mean. This doesn't make sense, I don't know. So they're saying it right, but then they say they don't understand it. So yes, if they're all the same, there's no standard deviation. A wide range, like stocks bouncing around, or the second one, all data have the same value. Everyone got 100 points on the midterm. If that did happen, that would be 0 standard deviation. A list that has 0 standard deviation is how many hours of sleep my kids get each night during weekdays, because it's always 10. Lucky if this is your kids. If only my kids slept that well. Or for this one, the high standard deviation numbers are very different. This one on the other side, there actually would be some standard deviation because there's 10s and 0s. They're not all the same. So if they were all 10s, then that would be 0 standard deviation. Frequency tables. So somebody just said appropriate things. How many pets do I have of each kind? That's great. Inappropriate would be breed, unicorn, and frequency. Sounds inappropriate. I'm not quite sure what they're talking about then because they're not telling me what they're counting. So this person said, here's a good frequency table on the top, how many people got each scores. And then they made a contingency table, which is sort of just a fancy frequency table. So I'm not sure that I would call that inappropriate. This one made me think, is it inappropriate to have dogs and cats as two different kinds of animals and then have their length and their weight? I think that's okay. People who have cell phones at different age groups. So that's a contingency table, but that's a good one. For the handwritten one, how many people like different flavors of ice cream? That's a great frequency table. This also seems okay. Do you want suspense, horror, or comedy? Maybe it's wrong because they think suspense and horror should be the same category or something.
That's where my thought process was with that one, is that's usually
that you can't really
horror
separate those.
have
Then that would
suspense.
make it wrong.
Yeah, because usually if you like are watching a horror movie, it has suspense. So like, how can you tell if it's a suspense or a horror movie? So that's where my thought process was on that one.
Mhm. Okay. A data set appropriately written in a contingency table. So here's a nice one, dogs and cats, male or female. And inappropriate, dogs and cats, birds and unicorns. So that doesn't make sense. You can't have a dog bird or a cat bird, right? So you couldn't put numbers here. A frequency of smell, then they're not putting numbers here. So they did a good job making a bad table. Right? If you're having a contingency table, you want to be counting how many times different combinations of things happened, not just labeling things. So this one's appropriate, different time periods, and are fruits or flowers or both in the paintings. Inappropriate, they just made a frequency table, not a contingency one. So yes, that's a bad contingency table. It doesn't have a second type of thing across the top. For this one, exercise is one thing, male or female is another. And then dance, snacks, again, without numbers here, then it's not a good contingency table. So good job putting words instead of numbers there. What makes a bad pie chart? So if you don't have a size to know how big to make the pie slice, for this one, somebody said, how tall are you? And that's another great way to make a bad pie chart. For a pie chart, if I go all the way around the pie, that should be 100% of something. That should be all of my whole. But it's not like the heights are parts of wholes. Just because Cynthia is so much is a certain height doesn't mean that Barbie and Amy are the rest of that height. So there's no part out of whole here, so you can't make a pie chart out of it. For this one, then, so they made a good pie chart, parts out of wholes with the frequency. And then for the contingency, then you have to tell me which of these things you're going to make a pie chart out of. There's too many contingent things happening at once. I don't know what to make a pie chart out of. So that's a good way to make it not work. For the handwritten one, colors, yep. But this is kind of an awkward pie chart because you made all the pie slices bigger than the two. But you certainly could make a pie chart out of that data. Then an inappropriate one, I thought this was interesting. So they said, if I wanted to find the degrees of the wedges, which they did correctly, take the relative frequencies and multiply it by 360 to get how many degrees would each wedge be, then labeling the degrees itself on the pie chart is wrong, because it's not like 144% of the people picked purple. It was 144 degrees out of a circle. So by changing the degrees of the pie chart to the wrong label of percent, they made a bad pie chart, which was a clever way to answer that question. A compliment, if it has an I, then that's not a math word. That's just, you look nice today, good job on the test, you're such a good parent, whatever, right? If it has an E, that means things that are two outcomes, and they are the only two possible outcomes. So I run to the top of the hill or I don't run to the top of the hill. You have to be careful to word them so they are completely everything and exclusive. You can't say I run to the top of the hill or I walk to the top of the hill, because maybe I go to the grocery store instead. So word it carefully, as this person did in blue, that I either did this or I didn't. I hit a home run or I didn't. I have a loaded coin. It's either a head or a tail. It's not going to land on its edge. I either put the right amount of mayonnaise on my sandwich or this one is not quite right. I put way too much. What are we missing out on?
The amount.
There's the not enough mayonnaise. So this one here doesn't work, because there could be a third category for what might happen. For this one, what percent, that's not really what we're talking about. We just want labels of outcomes. So getting enough exercise, yes or no, would work. But by putting what percent in, that's sort of not what we're talking about here. And then a simple outcome and a compound one. So let's look at this person's nice note to themselves. A simple outcome has just one thing that happens. It's what you actually asked in the survey. The compound event is a combination of two or more simple events. So if I shrink that back down, a good way to think about it is if I have a contingency table, the green ones I've highlighted are the simple events. People were asked, do you have a dog or a cat? And is it male or female? And then somebody got all those survey answers and made them into the green part of the table. You could use that survey data to answer other questions. How many total dogs are there, by adding up these two? So that's a compound outcome. You're adding up the things that were actually asked. How many cats are there? How many male animals? How many female animals? So if you have the word or and, it's a compound thing. How many dogs or cats are male? How many dogs and cats are male? Another way to do it is to have the words at least. So if you say at least in your question about the survey data, then you're probably having a compound thing. So here we have all the ways to roll two dice and add up their numbers. One way to roll a 2, 2 ways to roll a 3, because 2 and 1 is different than 1 and 2. So you could ask, how many ways could I roll a 10? So 1, 2, 3 out of 36 ways to roll a 10. 6 by 6 is 36 total. If I said, how many ways to roll an 11? More, then I'd have to add up all of those and I'd get 6 out of 36, and it would be combining the 10s, the 11s, and the 12s. So that would be a compound thing. So this one wasn't quite right. A 1/6 chance of rolling a 3 on a dice, that's true, but that's still a simple outcome. If you were to ask what's the chance of rolling a 3 or more, that would be compounding the 3 or more, the 5, 3, the 4, the 5, and the 6 all together. How many spoons do I have? If I was to randomly pick some silverware out of my drawer, then that would be a simple outcome. The compound would be how much silverware I have. Not really. It's more like if I was to pick something, what's the chance it would be a knife or a fork instead of a knife only or a fork only. Okay, questions about any of 5B?
I'm good.
Everyone's ready to move on? You can try 5B now if you hadn't before. Holler if you need more 5B. We're moving on. Okay, your turn to show off your quiz ability. If you did the quiz and want to write something on the board instead of me, now is your chance to get that achievement if you want to. So who wants to do number 1 from the quiz on our board?
Can we do it without writing?
Yes, just narrate to me. Or...
Okay, I'll do number 1. So it says it wants the percent change, so you have to use the formula percent equals percent change time or divided by original. And when you plug in all the numbers, I'll slow down for you so you can write.
Thank you. Okay.
And when I plug
Scribe
the
has caught up.
yeah, when I plugged the numbers in, it was 0.18 divided by 14.28. And I got those numbers based on the candy sales for the years. And then once you work that problem out and you do RipLop, you come out with, well, before RipLop, it's 0.01260. And then RipLop turns it into 1.26%.
Okay, questions on number 1? Thank you, Mickey. Okay, number 2, now is your chance to groan and hate me. This is a trick question. Here's a frequency table about automobile crashes. Somebody had compiled some data where they knew the ages of the drivers. And then they say, were you in a crash? Was there an injury? Was it a fatal crash? So remember from the personal finance decisions one, we had a histogram of test scores, and we could change the bin size to make the histogram shaped kind of different. So how big the bins are is a matter of displaying my data. How do I want to put it on paper to convince people of something? But the actual test scores, that's the thing that's either categorical or quantitative. Am I measuring labels like bird, cat, dog, or am I counting numbers like test scores? How I draw it, how big I make my bins, is a decision that happens later. So this quiz, the fact that somebody drew the table in such a strange way, with some age categories only being 2 years and some being 10 years, we might not like that and say that's a strange way to draw it. Makes it harder to look at the data and see good patterns and so on. But it doesn't change the fact that we are taking ages and counting them, and the ages are numbers. So the data itself is quantitative because we're counting ages. The fact that someone drew it in this table instead of some other table is not part of whether the data is categorical or quantitative, because that's a question only about the data we get, not how we present it. So hopefully, if you didn't get it right, don't feel bad. And if you did, congratulations. But both of those students were off on a loose end.
Do you think you could scroll a little bit? I don't know if you're writing, but I can't see anything.
Make it like that. Is that better?
Yeah, now I can see a little bit.
So the data is quantitative. What these students are saying, they're just sort of confusion. Don't worry about what they said. So we are counting them. We are counting ages. We're counting how often numbers happen, so that's quantitative data. Okay, and now you can all boo me. So I will quickly distract you by moving on to number 3. Who wants to do number 3 on the board, or you narrate and I will be your scribe?
I can do number 3. I'm not sure if I did it right, though.
Okay. Do you mind if I do a quick review of relative frequency first?
Nope.
Okay, so we looked at relative frequency last week. Here's a slide from Wednesday. We had just a frequency table to start with. How many people picked this as their favorite pet? And then we added next to each frequency the relative frequency. We added this column. And we did that by saying it's how many for that row out of the total. So 6 divided by 21 is 29. 5 divided by 21 is 24, and so on. So whatever Eli narrates, I'm going to draw something like that in my head, but I don't have to draw the whole chart for this test, or for this quiz, because your teacher was nice after number 2. Okay, so we are looking at the 60 to 69-year-olds.
And fatal crashes. So what I did was
fatal crashes.
Yeah, so I took the number for the 60 to 69 range. That's 1.04. Yeah, and then I divided it, and what I divided it by was all of those numbers in the fatal crashes column all added up. So 3.75 plus 2.47 plus 2.15 on down to the end, and I got 20.61 for that. That came out to 0.05. Which would equal 5% relative frequency.
Okay. A very common mistake was people were adding up these green numbers rather than adding up the yellow column. So if you did that, you are not alone. We just haven't done enough example problems of these in class. Okay, questions on the week 5 quiz? If you've turned things in and gotten credit for it, congratulations. If not, feel free to steal from this as your reward for being in class today. Okay, before we start our new topic of standard deviation, let's look at the midterm, because you've learned a whole lot, and I want to reassure you that the midterm will not be too bad. So what are the new things that we have with displaying data? What can I ask you? I can't ask you to really make a histogram. That's too much artwork for a test that in theory could be a timed test if we were not teaching remotely. I guess I could this term, but I don't want to get in the habit of making you spend a lot of time during a test. So I can ask you what are the mean of some numbers, add them up and divide by how many. I can ask you to find the median, put those in order, and pick the middle one of the ordered list. If the ordered list has 2, because there's 2 on either side and then 2 in the middle, then you would take the mean of the center ones, which wouldn't be 30 and 7 when I sort it, but you know what I'm trying to say. I can ask you to find the range. That's a really quick one. It's the biggest minus the smallest. So since you can use a calculator, that's a really quick, easy point. I could ask you to find the standard deviation. We haven't done that yet, but we will in just a moment. And you can do that, and that will be annoying, but you can. I can give you a frequency table and say, what's the relative frequency? So just like we did, 2 cats divided by the total number of animals, and I would find the relative frequency. Or I could say, if it was displayed as a pie chart, how many degrees in size would be this wedge for cats? So whatever I had here, so 9 plus 2 plus 9 plus 4 is 24. 2 divided by 24 is 8.3%. Then I would multiply that by the 360 degrees and get my answer. I won't actually make you draw the pie chart, but I'm just taking the percentage we found in 31 and multiplying it by 360. Continuing the previous problem, if the Animal Adoption Agency had 74 animals with amounts proportional to the table, how many would be cats? So I would take the 8.3%, that's the cats, and now I'd multiply it by 74, because we're saying what's 8.3% of 74, and of means multiply. Does that ring a bell from last week? Did I just lose anybody with examples 32 and 33? Should we do some more of those?
Yeah.
Yes.
Could we do an example of that?
Yes, we will. Let me keep going for just a, actually, no, I won't keep going. Let's just do these. Let me shrink it. I think it'll work. Okay, so I'm going to paste that. Move this away. Give me room. She wants room. Okay. Is that a big enough font on the Jamboard?
Yes. Yes.
Okay. So for the relative frequency, I added them all up. 9 and 9 is 18, plus 2 is 20, plus 4 more is 24. And then we did, looking at cats, 2 divided by 24, which was 0.083 repeating forever, so about 8.3%. This decimal version is more useful when I'm doing future math. So for 32, I'm going to take the decimal version with lots of 3s, right? And I will multiply it by 360 degrees for the full circle of the pie chart. And get 30 degrees. .33 is very similar. I'm going to take that same relative frequency written as a decimal because that's what my calculator likes. And now instead of 360 degrees, I'm multiplying it by 74 because there's 74 animals. And I would get about 6. Should we reload it and do more numbers, or is that enough?
That was
I think
helpful.
that was good.
That was enough? Okay. So as always on the practice tests, if you really want more and are just being shy, it has the answer key. So it tries to explain things for you. Then we're going to do the next one. Now we have not just a frequency table, but a contingency table. So on a dark and stormy night, a certain disreputable tavern in Waterdeep, a famous fantasy city, has the following customers. There's elves, dwarves, and gnomes. That could be wizards, barbarians, or rangers. So first we ask, what percentage of the total customers are gnomes? How would I answer that?
We have to add up all of the numbers.
For the gnomes, right, Eli?
I think we have to add up the total population first. So we have to find everybody, and then we add up the gnomes. And we divide the gnomes by the total population.
Yeah, you could add things up either way. Doesn't matter who you count first, but you do have to do gnomes divided by everybody. Oops, and then I can spell, I'm thinking about gnomes instead. So how many gnomes did we have? 6 and 5 is 11, plus 1 more is 12. What's everybody? Let's see, 7 plus 3 plus 5 plus 3 plus
34.
8 plus 1 plus 12. I got 39. Somebody double check.
Yeah, I'm getting 39 too.
39.
I got 39 as well.
So 12 divided by 39 gives me about 0.3. So 30%. For 35, it is still part divided by whole.
But this
But
time
now we're just
counting the
wondering,
distance, right?
right, now the fact that we have 12 gnomes, then that's going to be our whole. And the gnomes that happen to also be wizards is the part. If I wanted to be very tricky, which I cross out the words of the total customers. If somebody did ask you what percentage are gnomes, the implication is that the whole is the total customers. But for a test, when our brains are tired, that's going to throw too many people for a loop. So I will be explicit both times. What is the part and what is the whole? Do we need to do another example of this pair?
So what is the gnome wizards? Percentage of the gnomes are wizards. So you could took that.
6 these creatures are gnomes and wizards. But all of the gnomes is 6 and 5 and 1 is 12 of them total.
Okay.
So what percentage of the gnomes, the whole is all gnomes,
Okay. All gnomes.
also wizards.
Okay. Thank you.
Mhm. Should we do another one like that?
Yes, please.
Yes, please. Okay. So that's slow. If I have time, I will edit this so that it doesn't always have the same names of things, but we'll see. I have been ridiculously busy. It doesn't change as much. $34 part divided by whole. What is our part and what is our whole?
So on this one, wouldn't it be, the part is 2? Oh, no, I'm sorry. 11.
I want words first. I want something like gnomes or wizards, something like that. We'll get to the numbers later.
Wouldn't the part be the dwarves, and then the whole would be the the whole would be the
Yeah,
total?
part is all the dwarves, and the whole is everybody. And I encourage you to write this line. Just like when we did finance formulas, writing the sort of preparatory work in the middle of the problem that I did in blue font was the trickiness. Then if you skip this and try and put numbers in right away, then that's where you will make your mistake. Okay, so how many dwarves are there total?
11.
So 2 is 11. So 11 dwarves. Nine, 10, 11 total is going to be 30. Did I do all my mental math right? And then 35, I again have a part divided by whole. What is my part and what is my whole? Words first and then numbers.
would it be rangers as part, and then as a whole, would it be all dwarves?
The whole is all dwarves. But the part, I can't just use the word rangers, because if I did that, it would include the elf rangers and gnome rangers also.
Wouldn't it be just 2 for the dwarves that are rangers?
Right. We're only looking at the dwarf rangers, which is just 2, and all dwarves was 11. So I get 0.18181818 forever, so about 18%. Does it help if I mark things color-wise that the dwarf rangers are here and all the dwarves are here?
Yeah, that helps. Thank you.
So we're asking what percentage of the dwarves, meaning of all the dwarves and rangers. Okay, the last problem, there are these 4 histograms that we saw earlier with different standard deviations, and I want you just to explain with words which has the greater standard deviation. So if it was A and C, which one has the bigger standard deviation?
A.
A. If I looked at the middle value, there's more things far from the middle on A. C has a lot of things quite close to the middle. If it helps, think about it like a teeter-totter. If I, do I have a free Jamboard or did I use them all up? No. If I was to draw a teeter-totter under these, then in A, more kids are sitting at the edge of the teeter-totter, way at one edge and having an exciting time. In C, most kids are sitting right by the fulcrum of the teeter-totter and not moving very much. So more exciting teeter-totter, bigger standard deviation, farther from the middle, farther from the balance point. Okay, let's get rid of problems. Too many problems on this test. So which of the problem-solving problems do you want to get rid of or keep?
Let's get rid of number 7.
Okay, getting rid of 7 makes sense.
I don't think we need number 9.
9 is really annoying with chain discounts. Do you want the compound sale for number 8?
I don't think it's necessary.
Yeah, I agree.
Also, 1 and 2 are kind of similar. I don't think we need both. Three is nicely different. It's often done with a proportion rather than just a change divided by original. So I think 3 merits sticking in. Is it good to have both margin and markup to keep you fresh about the difference between those?
I think they're useful. I think the mortgage problems are really useful too, because those you can directly apply to real life. I mean, these you can apply to real life too, but the mortgages.
I'd say take out one.
What if we keep 1 and then 3, 4, and 5?
I personally don't like any of them.
You don't like number 1?
No, I said I don't like any of them. So if you get rid of any of those, I would not be sad.
I think 1, 3, 4, and 5
Let me
are
make a
good
note
ones.
to myself. 1, 3, 4, and 5. Okay, I'll just make it right there. I didn't do that. Oh well, I have it to myself, even if you can't see it on yours for some reason. Oh, that's because I put it in the wrong spot. I put it in the insert key. Okay. Come on. Okay, keep 1, 3, 4, and 5. Finance, the mortgage ones people like. $15 was the one that you could sort of cheat on and just subtract some things. So I'm happy to get rid of 15.
I really like that one.
You like that
Because it's an easy one.
Easy one? But you have some easy ones in displaying data too, of like biggest minus smallest. So you get some other easy ones. Do you want all the steps of mortgage problem, or should we get rid of those?
I like the mortgage ones.
Get rid of stuff.
I'm thinking these are sort of the key things of which ones do you want. We can get rid of Sir Topham Hatt and the,
Get rid of 25 and 26, the 2-step ones.
yeah, let's get rid of those. And let's get rid of 50.
Time.
So we're keeping 10 to 14. Do I need to ask you which formula to use and which clues? Is it helpful to keep yourself organized to make that explicit?
Yeah.
Yes, reminders are great.
Reminders are great. Okay, so we'll keep all of 17 to 24. Okay, so let's count how many problems we have then. So 4 problems for problem solving. 10, 11, 12, 13, and 14 would be 5 problems here. And then 8 problems here. So 5 and 8 is 13, plus the other 4 is 17. 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So a little long, but 4 of them are just the reminders. So I think that might be okay. I could make 32 and 33 alternate between the same thing. Half the time it asks you about a pie chart and half the time it asks you about an animal adoption agency.
Are you saying pretty much combining 32 or 33, depending on which time you do the test, it'll change that question?
So I could do that, but they're kind of easy points. So I'm not sure if having fewer easy points.
You said it was 27
Happy or not.
altogether so far?
I think so.
I think that would be fine because I believe that's one more than what the other one was. And like you said, we have those 4 easy ones that's just answering it to help us set up for the following 4.
Mhm. Okay, any other comments before we're done with this? Somebody said, I want Sir Topham Hatt to tell me how useful I am. Okay, well, I'm going to close this tab. Holler at me in some other format if you have other feedback about the test problems. Okay. Standard deviation, finally. Are people feeling, before I close that tab actually, are people feeling ready more or less for the test? We'll do standard deviation, we'll review more on Wednesday. These problems, now that you know what's actually going to be asked of you, do they seem okay? Has the homework prepared you?
Yeah, I know for me, it was really helpful to go through the homework so comprehensively, because then I can just go back and do a lot of those problems on my own and just do them as many times as I possibly can. So that was great.
Yeah, I think once we
Could we do like,
go ahead.
could we do like one more on standard deviation possibly?
Yes, we're about to do a whole section on standard deviation. What were you saying, Ashley?
I was just saying that I think for me, once we go over the standard deviation, I'll feel more confident because that's the one that I'm struggling with the most.
Okay, that's because I haven't taught it yet. So. Okay, welcome to standard deviation. This isn't hard, it's just a long process in a purple box. And you get another word named variance for free. When we get to step 4, then every now and then you will have some odd thing in your life, maybe never, where someone will care about something called variance, and that just means stop at step 4. So once we learn this 5 steps, you'll get both a variance and a standard deviation. But variance is used so rarely that it's not even going to show up on your test. Okay. I want a very small data set. So way back from the personal finance page, when we talked about histograms and means and medians, we had this picture with this data set. Our numbers are 2 and 2 and 6 and 10. And your challenge a long time ago was double check that it really does balance at 5. So we had our mean is the sum divided by how many. So we'd add that all up, 2 and 2 and 6 and 10 is 20. Divide by how many, which was 4 and 5. So yes, 5 is our balance point. 5 is the middle of this life is good. Everyone okay so far?
Yep.
Okay, so somebody is going to say, how spread out is this data? So step 1 in our purple box is maybe it would work if we just found the deviations. So for each of our boxes, data piece isn't quite the right word for each. There. So if I'm at 2, I'm 3 less than the mean, so I have negative 3s. If I'm 6, I'm 1 bigger. If I'm 10, I am 5 bigger. So good so far? If I was inventing this for the first time, I might try something that doesn't work. So don't do this. I'm about to erase. The wrong idea would be to say, what's the total deviation? That sounds like it's going to tell me how far apart things are overall. But if I do that, my -3 and another -3 and a 1 and a 5, everything cancels out and I get 0. So I can't just add up my deviation numbers. They will balance out and come to 0. Do you see why they come to 0?
David, admittedly, I don't.
You don't.
I don't see any of this. And this
Oh.
little chart that you have here with the numbers or whatever that is, it looks like a battleship. None of this is working for me.
And this is working?
Sorry.
Okay. Let me not use the picture then. And let me just put that by each number. The 2 was 3 less. Whoops, with a pen. The 2 is also 3 less than the 5. The 6 is 1 more, and the 10 is 5 more. Is it better if I put the numbers there?
-3, -3.
And they are 3 less than my mean.
Okay.
The 6 is 1 more than my 5. The 10 is 5 more than my 5.
It's kind of like a number line in a way.
Mm-hmm.
2, 6. Okay, okay, yep. Thank you.
So when I add up how far they are from the middle, whether left or right, the whole point of the middle is it's going to balance. So it's always going to be true that the negative ones and the positive ones are going to balance out. If they didn't, I must have messed up when I found my middle.
So why do we have 2 there twice?
Because somebody just measured things, right? These are my 4 data points. Someone was counting how many animals of each kind there were, or something like that. There's a 2, a 2, a 6, and a 10. The weights of small children: 2 pounds, 2 pounds, 6 pounds, and 10 pounds. So they'll be awfully small. The weights of large lizards. There we go. So if you are following me well, then by now you see that there is some problem. I want sort of an overall sense of how big are my deviation numbers. How much is each data point distant from the middle, from the balance point. But when I add them all up, that doesn't tell me overall how things are, because it will always just, the negative ones and the positive ones cancel out and we get to 0. So I have 2 ways in arithmetic of solving this problem. The first way is absolute value. I could say, let's just pretend all of my -3s are +3s. And then I could say the total deviation is 3 + 3 + 1 + 5. How far are things away from my middle point? I will say this counts as 3, not -3. So that would be one answer. And the math would be a little easier if that's what somebody decided when they invented this. But for some kind of complicated reasons, they decided that the other thing you can do to get rid of negative signs is to square a number, because a negative times a negative is a positive. So step 2 is that once we have how far each data point is from the middle, then we will square those. So the -3s will become 9s. 1 times 1 is 1, and 5 times 5 is 25. And I'm going to keep writing with my red pen. That this one was -3 times negative. This one was 1 times 1 was 5 times 5. So my first step was find the red numbers. Take each data point and see how far it is from the middle. My second step is take each of those numbers and multiply them by itself and get this list of the squares of the deviations. At this point, you don't know why we're doing this. Because it seems like we've stretched things, right? This 10 is 5 on the number line, distant from the middle. It's not 25. It's like it's a rubber band number line, and we just stretched it to be bigger for no justified reason. The next step would be to sum those squares. So we have yellow is there. And then we're going to divide by how many? And these two steps together should ring a bell. Add them up and divide by how many. We are finding the average. We're finding the mean of the squares.
Is the dividing part step 4?
Yes, that's step 4. And at this point, if we stopped, we would say the variance is 11, but again, chances are you'll never use the word variance in real life. So stick it way in the back of your brain as a back burner item. But then step 5, we stretched out the number line like a rubber band, right? We squared things. So 3s, 1, 2, 3 steps away became 9 steps away. Or 5s, 1, 2, 3, 4, 5 steps away became 25 steps away. So we need to undo that. So as our last step, and let me put this in a box so it doesn't blur. sorry, I'm out of room and going backwards, and I'm blind. And somebody is going to say I'm too much at the bottom of my screen. Let me try and fix this out, whatever that is. .3. So that's my standard deviation. It says on average, I'm going to make some measure for how far away from the middle these are, which is a kind of weird game with all the squares and square roots. We all admit that. Then I'm going to say for this data set, 3 is my answer, 3.3. It's about true that things are about 3 away from the middle.
Hey, David,
And you can see that that would get these, but not that one. Yes.
could you pull up the calculator and just show how you do the square root on there?
For the calculator up here, I just do square root 11, and there it is. There's a square root key right there. If you have a sharp calculator, like I'm holding up in front of my face, the square root key is, I have to do brown second function button, and then the x squared key. The square root is hiding kind of above it in brown. If you have a Casio, I don't know. Excellent question.
I have a sharp and it's just a key.
It's just a key on yours. Okay, good. That's nice.
I'm not getting it.
Let me see if I can do this. Timeliness. So if you can't see it, then I am now taking a photograph of my own calculator. Maybe yours is like mine. It's taking forever to load. La, la, la. Do I give up? I don't know. While we're waiting, if you didn't remember to bring 2 6-sided dice, and have them handy at your house. Go in and get them, because that's what we're doing next. We had a perhaps too simple data set with only 4 numbers. So we're going to generate some bigger numbers. Look at the standard deviation then. Paste it again. It's not that big. There we go. Okay, so if you can't find it in your calculator, is like mine, then I have to the squared key because it's right there above the squared key. Anyone else can't find it on their calculator?
I can't. But mine is, maybe it's not enough of a calculator. I don't know.
Could be. You had just kind of adding machine style calculator.
Yeah.
You can
Here.
always use the Desmos one at the top of our website. And square root then doesn't get any easier than that.
Okay.
Okay, let's do this with some bigger data. That's actually more interesting. So I took our spreadsheet that we're doing lots of stuff on bit by bit, and I made up something that will make a histogram as we go with the sum of 2 dice. And it will tell us these numbers, but don't worry about them yet. We're just looking at the top of this. And I zoom in, zoom, there we go. So how this works is I have just put in some sample things. Ash rolls 2 dice 10 times and gets 1 3, 2 5s, 3 7s, a 9, 2 10s, and a 12, whatever that may be. Then you can see the histogram changes as we go. So I'm going to erase all of my sample values so far. And we'll start from 0. How many people actually have a pair of dice to do this?
I do.
You do. Okay. Let me see if real quick I can find a website that's like rolls 2 dice. Okay, yes, if you just search in Google for roll 2 dice, then there's plenty of things that seem to do that. One of them wants cookies. I don't trust that. That one's kind of fun. Okay, I'll put one in chat. Chat to everybody. Roll 2 dice. Okay, go ahead. So roll 2 dice 10 times, record your numbers, and then when you get my attention, call them out, and I will record them in our spreadsheet.
So I have 1, 2.
1, that's sum of 2, okay.
2 3s, 1 4, 1 5, 2 7s,
The last one, I'm sorry.
2 7s. Oh, sorry, 1 5.
Sevens.
Go back up to 5 and add 1 5. Yep. 1 9.
Okay, one moment. It occurs to me I should put, I'll have this already, but I'm going to also put it in our, if you can enter your own to save me time, all the better. Okay, 1 9.
Yep, 1 10 and 1 12.
Okay. We know that this will make a bell curve if we roll the dice enough, but notice that 10 dice alone don't work. Just Eli's sample doesn't look like a nice bell curve.
So we're giving you the sum of what we like rolled for one round or 10 times?
Yep, 10 times, roll 2 dice and add them up. Actually, it might help just to use a smaller data set first. Pause your dice rolling. Thank you for doing that. But pause right now. Let's look at how to actually get the standard deviation. So first we need to find the mean. With the frequency table, when we're adding them, we had 1, so that's 2, but we had 2 3s. So remember, we had to multiply these. 2 times 3 is 6. We had 1 4, so that's just a 4. We had 1 5, that's just a 5. We had 2 7s. 1 times 2 is 14. We had a 9, a 10, and a 12. We add them all up together. There were 62. He rolled 10 times, so his mean is 6. Are we okay with it? Then for each thing, we had to say how far away is rolling a 2 from rolling 6.2. So that would be 4.2 away. How far away is roll 3 from 6.2? So that's 3.2 away, and so on. And some of them are bigger and some are smaller. It looks like maybe I did this backwards compared to what we did earlier in class. So I will fix that. Make the early ones the negative ones. Then we take all of those deviation amounts, that was the red numbers on the other page, and square them. We got our number line by making everything positive. Then I want to add up the squares and divide by how many. So again, I have to multiply them by how many there were, just like on the page. If we had 2 9s, I have to count both of them. So when we had 2 3s, we had to count the deviation that went with 3 twice. And once I had the squares, I add them all up and I divide by how many, and I get my standard deviation. I'm not going to. So that's the same process we did on the slide. For each sum of the dice, how far is it from our mean? it's 3 away, it's 1 away, it's 5 away, or in our case, it was 4, 2 away, 3.2 away, because the mean wasn't a nice whole number. Square all the numbers and then find the average. Take this. So if we go, if I add them all up, I got to 62. A 2, 2 3s, a 4, a 5, 2 7s, a 9, a 10, and a 12 got me up to 62. The average was 6.2. If I tried to just add up those deviations, then the negative ones and the positive ones balance out. So adding up how many will always be 0. That won't help me at all. But if I square them and add up the squares, I get something. And then forget the one left. How many squares were there? The same as how many data points there were, because every data point turns into one of these squares. And then the total divided by how many for those squares is the standard deviation. Okay, who else has dice?
I got my answers.
I do.
I'll put them in if you call them out.
Okay,
I
for my first
have-
roll,
Good.
If you can click on the spreadsheet and take your own in while I'm helping Val, that will save time. Okay, Val, what were yours?
so for the first roll, I got 7.
So 1 7.
So I got 1 7. Actually, 2 7s. I'm sorry.
2 7s, okay.
3 6s. 1
3
2.
6s. 1
1
2.
1 3. 1 8.
1 3.
Sorry, it keeps on cutting out like so bad. 1 8 and then 1 5.
Another 8 and 5.
Mhm.
Okay. Someone in chat asks them this individually. Or take. Okay, Zoom crashed, but we're back. Go internet. You are trying hard. Good job. Does someone else want to call out some numbers?
I have mine. Should I go?
Okay. Yep.
Okay, I got 3 6s, 1 10,
3 6s.
1 10,
1 of the 10s. Okay.
1 7, 1 9, 1 2,
1
1
more 7. Okay.
1 2, and oh, did you get the 9?
I got a 9.
Okay, cool. And then I
Two
got
more.
1 2, 1 8, 1
8.
11. Yeah, 1 11 and 1 5.
Can you share your screen again, David?
Oops, when Zoom crashed, it turned off my screen. Okay, sorry, there we go.
Sorry, I just
So I put in Jaden's numbers. Thank you, Jaden.
yeah.
So we still don't have a nice bell curve. The numbers 7 and above are starting to get shaped nicely, but we have a disproportionate number of 2s and 3s. Some fondness for snake eyes with our random luck. So
I can give you my numbers. I got 2 5s,
2 5s,
2 6s, 1 7, 2 8s, 2 10s, and 1 12.
I'm going to stop for now because it's 3:50. If we want, we could play with this more on Wednesday. You are welcome to click on it and add some numbers yourself and watch how things change. The more the numbers are clumped up in the middle, the smaller the standard deviation will be. If I just take everything 10 and above and get rid of it, see how the standard deviation just dropped down? I want to undo. So the more things are clumped, the smaller they will be because I have less distance from the middle. And all this weird game of squaring things, finding the average of those squares, and then unsquaring it, that's really all we're doing, right? Squaring those deviations, finding the average, and then unsquaring it. Then that's just sort of measuring how far away from the middle things are.
David, I clicked on the link to get to the spreadsheet, but it's only allowing me to view only. It wouldn't let me input my own numbers. And then I requested.
Okay, so I will have to just share it with people. One moment then.
I'm having the same issues, but when I try to open the link, it's a totally different thing than what you're.
You might have to click tabs at the bottom. Right, because we have 4 different tabs going. Let me invite it so that everyone can edit, because maybe you're only invited to do it and not to edit it.
Have just partnered up with Japanese Yuchara icon, Tomato-san! Dance, dance!
Okay, now you should all be able to.
Tomatoes, of course. Won't be able to afford her accordion lessons. How will I ever learn the polka?
Not letting me mute. Okay, there she muted. Sure, anyway. Okay, now you should all be edited to invite. Okay, bring your questions to class Wednesday. If you want to take a practice test this early, you can start your homework early and bring those questions to Wednesday. Hopefully knowing specifically what's on the agenda for next week's test will make everything easier. I'm going to stop the recording. If you